In the last video, we used gfortran on the command line to compile a simple program called hello.f, and we did it in a couple of different ways. We put our program in a directory called hello0, and we generated a couple of text files by using --help on the gfortran command and the ld command. So that's in our directory called gfort. We'll now make a directory, make dir hello1. Let's change into the directory and then copy hello0 /star.f. Star is a wildcard. Okay, we've copied it to this directory and we'll open the old hello with Notepad. There it was. Program hello, end program hello, and in between the only executable statement which wrote hello human to the screen. I'm just going to make a small interjection here. In the following, fun1 and fun2 and sub1 could be called anything. You could have called them Jesus, Mary and Joseph, or you could have called fun1 the Father, fun2 the Holy Spirit, and sub1 the Son, in whichever order you want. So functions don't have to be called fun, they don't have to be numbered, and the same things goes for subroutines. Subroutines don't have to be called sub. Now, as you can see, I've just changed hello.f. So we have the main program called hello, and that's all it is. The main program is between program hello and end program hello. Now, what you usually do when you're writing a program is you split whatever task up into smaller parts, and quite often you handle those smaller parts using things called subroutines or functions. So here we are. This time we're going to hand over that right to the screen to a subroutine which we've just called sub1, because it's the first subroutine. That begins with subroutine sub1 and finishes with end subroutine. And you can see I've just compiled it as I did hello.f with the -o option, and lo and behold, it prints out hello old chum ! So what happens is the program begins, it sees the statement call sub1, it hands over control to the subroutine. The subroutine has one executable statement in it. It's no longer hello human, but hello old chum. When it reaches end subroutine, it passes back control to the main program, and then it encounters end program hello, and the program finishes. If you're a C person, you could more or less regard sub1 as a function, except with no return value. The thing is, in C you'd call the return value void, but there's no void type in Fortran. As well as subroutines, Fortran has things called functions, which are similar to subroutines, except they do return a value. Well, I've added to hello again. So this time we've declared an integer called fun1. An integer is just a counting number like 1, 2, 3 or 4. It includes -1, -2. We can have negative integers, and of course we can have 0. Integers are 4 bytes. So we declare fun1 as just an integer, but fun1 is in fact function1. I've declared another integer called iReturn. So after calling sub1, iReturn is set to the return value of the function fun1. So when it encounters iReturn equals fun1 with the empty brackets, it knows that it's a function. So it passes control over to fun1. Here we are. This defines what the function fun1 does. Integer function fun1 has to be the same type. It writes 6, star. As my usual habit is using 6 for this. That's the standard number for the standard output. So that's writing to the standard output the message, "Couldn't lend me a tenner, could you?" Fun1 equals 7. That sets the value of what function 1, the integer, is going to be. And then we have a statement return and then the end of the function. So when it goes back here, the next statement is another write statement. Function fun1 returned, iReturn equals, and then the value of iReturn with a comma. So that's even more Fortran. And here's the result of compiling it. It now says, "Hello old chum, couldn't lend me a tenner, could you?" Function fun1 returned iReturn equals, you remember that line, and 7. So fun1 is an integer. It's set here, fun1 equals 7. iReturn has been given the value of fun1, and we see it's all worked fine. I'm going to make another alteration to the program. So what's going on here? Well, we've added an integer function fun2, which is almost the same as function fun1 was just a moment ago. But function 1 has changed. We now declare an integer fun2 and iReturn. And here function 1 calls function 2. And we have a similar thing that we had before. We check out the value of iReturn. So let's compile that. I'll use the up arrow keys. We've got an error. It says that it's an unterminated character string, but we have terminated it. Well, we just saw that didn't compile. Well, I explained earlier on that I'm an old Fortran 77 hack, and this is the dialect of G-Fortran that is based on Fortran 77, and that has various rules about the columns. That by columns I mean characters basically. So that's column 1, 2, 3, 4, 5. You can't go beyond line 72. This goes right back to the days of punch cards, believe it or not. So that line that I had earlier on was just too long. So I need a continuation. So I've got my write statement, but I've actually put what's going to be written on the next line, and this continuation here is the one that I usually use, has to be in column 6, and things like end function have to start in column 7 or later. So you can start them in column 10, column 12, whatever you like, as long as it's not earlier than column 7. That's a bit of weird Fortran for you. Now I'll just use the upper arrow key and then run it. and we can see one side of a conversation. We'll call him Bob. He says to Alice, "Hello, old chum," with an exclamation mark. Alice gives a wry smile but doesn't say anything. Then Bob could say, "Couldn't lend me a tenner, could you?" Alice just shakes her head and doesn't say anything. And then Bob says, "Oh no, that means I shall have to ask my dearest mamma." So that's what our hello program now does, basically. Function 2 returned I return equals 8. There it is, fun2 equals 8, that's right, return. And then function 1, as before, has returned 7 once it gets back to the main program. So what's the point of all this? Well, we've demonstrated the very simplest of functions, no data is being passed to them or anything, and subroutines, and unfortunately that meant me trying to teach a little tiny bit of Fortran. But the main point is what happens next. I've just used Notepad to open sub1.f, fun1.f and fun2.f. These files have got nothing in them at the moment, but as you can see, I've cut out fun1 and fun2 functions and the subroutine sub1. I've cut them out of hello.f and I've put them into separate files, fun2.f, fun1.f and sub1.f. In other words, the subroutines and functions are now completely separated from the file containing the main program. As you can see, my next step here has been to compile each of those, fun1, fun2, sub1, as well as the main program hello.f, with the -c option, which means we have object files for fun1, fun2, and so on. Here we are. You can see all the object files, and now I've done gfortran -o hell, so that's going to be our executable file, and then a list of all the object files that are needed, and gfortran would have called the linker, or some people call it the loader anyway, and it should have joined them all together and produced the executable file, and there it is. So the main point here is that we can have all our functions in separate files without being in the main program at all. We can compile object files and link them all together, and this is the way that we're going to build things like archives and libraries.